Hi students, let's start with mensuration today. Now what is mensuration? Now, yes, some of you might be guessing these words. I have received so many words from you: area, cube, solids, volume, shape, square, perimeter. Okay, now let me give you some definition about mensuration. Mensuration is a branch of mathematical science that is concerned with the measurement of areas and volumes of various geometric figures. Let's classify them into 2D mensuration and 3D mensuration. We begin the day with learning about 2D and 3D shapes. So, to observe the 2D and 3D shapes closer and to understand the formula for perimeter, surface area and volume, which is the lesson objective for the day. We begin with topic 1, 2D shapes, area and perimeter. Now, before we start, I would like to know how many of you can distinguish a perimeter and an area. Let me start with an example. Peter has a park next to his home. Every evening, he makes it a point to walk around the park. Now, as he walks, what is the distance that he travels from the starting point? Here, let's mark it as A. And he completes one round around the park. What should be calculated here to know the distance he moved? Is it the perimeter or the area? No doubt, it is the perimeter. Now let us find the region that is covered by the grass and the pond. In this case, for sure, we have to find the area. Here, it is a square region, and for sure, we are going to calculate the area of a square. Let me give you some more examples. You have a triangle. The perimeter of the triangle is just the border, and the area is the region inside. That's a trapezium. Now the perimeter is just the outer border and the area is the red part. A rectangle. The border is exactly the perimeter that you calculate and the area is the green region. I hope now you have a clear idea to distinguish between a perimeter and the area of a figure. To keep it simple, let me say, for the perimeter you just add all the sides, and for the area we have to learn the formula. Let's consider the side of the square to be 8 centimeter. In that case, the area of the square is a square. Did I say something wrong? The area of a square is a square. I hope that is easy to remember. The area of a square is a square. So you just multiply the sides to find the area. That's easy. Now let's summarize what we have learned. Number 1, square. All sides are equal, so we consider the sides to be equal to A. So the perimeter is going to be the sum of all sides, so which is equal to 4A. The area of a square is a square. The next is a rectangle. We have the length Now some of you may use the letter W, which denotes width, instead of B. Both are appropriate. The perimeter is just going to be the sum of the border, which is 2L plus 2B. Or you can take the common outside and write 2L plus B. The area is again the length multiplied by the breadth. For a triangle, let us consider the sides to be A, B and C. So, as we know, the perimeter is going to be the sum of all sides. So, A plus B plus C. And the area of a triangle, you have to consider the perpendicular height. Now here I take the blue line here. Can you see this? Okay. Now this is my height. The height should be the perpendicular line. So look at the similarity with that word height. So the area of a triangle is going to be half times base times the height, which can be denoted as half times B times H, or you say BH over 2. Now, let me tell you something. Look at the similarity. Whenever you talk about height, the height should be like this. It should be the perpendicular height. Look at that H there. Can you see the H there? So the height is something that makes a 90 degree. It should be perpendicular. This is your height. Okay? So that's about a triangle. Let's move on. Consider a new concept. I consider triangle ABC with side AC as B and side BC as A centimeter. The angle in between the sides A and B is the angle C, which is marked in yellow. Now before giving you the concept, let me say I'm introducing a new formula. Now this formula is used when you don't have the perpendicular height given to you, but you know there is an angle that is sandwiched between the two sides of a triangle, which is known. Okay, so let me introduce the formula. Its area is equal to half AB sine C. So you can see the function there, the sine function coming in. Now, let me remind you, C is the angle in between. Now let me give you two figures to remember this when to consider the angle and which side to take. Remember your sandwich and a stapler. It's the same way. You should know the sides, okay, and the angle in between. So only in this condition you can use this formula. So don't make mistakes by taking the wrong sides and the wrong angle for the calculation. Be careful, you take the angle sandwiched by the sides. Okay, so let's go for an example to see how to apply this formula. Find the area of the triangle shown in the figure. You have triangle ABC with sides BC and AC given to you. We have the angle 52 in between the sides. So applying the formula, area is equal to half times. Here we will take the sides as 7 multiplied by 5 times sine 52. So we have the sides and we have the angle in between. Now use your calculator, and from your calculator you get 13.79018. This is your answer. Do not forget to write your answer to 3 SF and to put the right unit. So this is your answer to 3 significant figures. What shape is this? I can see the opposite sides are equal and parallel. So no doubt it is a parallelogram. Now what is the area of a parallelogram? Let us name it ABCD with B as the base and H denotes the height. Now again, the height is the perpendicular distance between the two parallel lines. The area of a parallelogram is equal to base times the height. We know that a parallelogram consists of two triangles when they are divided by the diagonal AD. So the area of a triangle is base times height over 2. So adding two areas together, it just becomes base times height. So take note of this. We will be knowing another formula which can be used when you have an angle and the sides adjacent to them are given. When we are given the two sides and again a sandwiched angle there. So the formula will be AB sine C. AB sine C, reminding you of the sandwich again. AB sine C. The angle is sandwiched between A and B. Now, if you have the sides of the parallelogram given to you, the perimeter is going to be the sum of all sides. So, which is again 2A plus 2B, or it's again 2A plus B. The area of the parallelogram can be given by base times height. Remember, height is the perpendicular distance between the parallel lines. And the second formula that we have learned is area is equal to A times B times sine C, where C is the sandwich angle between the sides of length A and B. Let me just mark it here. What shape do you see in common among the three figures here? I'm sure you have found the answer by now. It is a trapezium. Some trapeziums in real world. First of all, it has the parallel sides, which is considered to have a length of A and B. Apart from which, we consider the perpendicular distance between the parallel lines, which is considered as the height h. Now, area is given by half times h times the sum of parallel sides, which can be rewritten as area is equal to 1 over 2 times h multiplied by A plus B. Now, some of the trapeziums that come before you may look like these. In all these cases, you must easily identify the parallel sides to take them as A and B and the perpendicular distance that gives you the h, the height. Again, look for the parallel sides, mark them A and B and try to find the perpendicular height. In this case, you have the parallel sides and this is the perpendicular height, which is denoted by the letter h. So that's it. Now let's move to the last shape for the day, which is a kite. For a kite, we use the diagonals to find the area. Let us consider the diagonal AC as D1. The whole length is considered to be D1 and BD is taken as D2. So the area of a kite is given by half times the product of the diagonals. Or you can say it's D1 D2 over 2. You multiply the diagonals divided by 2. So that's about a trapezium and a kite. The next part is applying the formula to the numericals, and let's see how we can solve them. Watch the next video to start solving questions applying these formula. Thank you for watching.